Hi, so for today, we're going to talk about the homogeneous differential equations part 4. Basically, we're going to continue our discussion all about the homogeneous differential equations. And again, we have this following formula, and we say that a differential equation is a homogeneous differential equation if each and every term has the same degree. Okay, so in this case, for number 1, okay, we have x squared, that's second degree. The other term is 2, okay, y squared, second degree also. And then we have here xy. We have a degree of 1 for x and a degree for 1 for y. So that still, same term, one term, they have second degree. So we can conclude that this is a homogeneous differential equation. And we have the following substitution to be made. If m is simpler, we have x equals by dx equals b dy plus y dv. And if n is simpler, we have y equals bx, dy equals b dx plus x dv. So in this equation, or in this differential equation, we know that n is simpler. So what are we going to do is to let u, or let y, I mean, let y equals bx, and we have dy b dx plus x dv. Okay, so basically we are going to substitute all of the y into bx and dy into b dx plus x dv. So we have x squared plus we have bx because that is y, and it is squared. So we have dx minus x multiplied by y here. So we have vx. And we have dy. So we simply substitute it with b dx plus x dv equals 0. So we perform simplification for this. So we have x squared plus b squared x squared. And we have dx, and we have vx squared here multiplied by v dx plus x dv equals 0. So simplification, x squared dx, I can multiply dx. So we have b squared x squared dx. Distribute, okay, to this. So we have, don't forget the negative sign. So we have b squared minus b squared x squared dx minus we have bx cubed dv equals 0. And as we can see, b squared x squared dx positive minus b squared x squared dx would cancel, so that we are left with x squared dx minus, okay, bx cubed dv equals 0. Okay, so continuing our solution, so I can factor out x squared, okay, because it's both common, okay, here. So we have minus vx dv equals 0. So I divide both sides by x squared, okay, so this cancels. So we have dx minus vx dv equals 0. And we can solve this through separation of variables. So we have dx all over x, okay, minus v dv equals 0. So now, we have already separated all the x with the dx in the first term and all the v with the second term, okay, into dv. So it's time to integrate, okay? And then what are we going to do is simply get the integral of that. We have ln of x minus v squared all over 2 equals c. Okay? Multiply both sides by 2. So we have 2 ln of x minus v squared equals c. Now, in this problem, I only have 1 ln as a term. So I'll be converting this constant into ln, okay, to simplify this ln of x. So I would also consider the sign when I transpose this c. Okay, so we have 2 ln of x minus c. Transpose this v squared on the right side, this becomes positive. So now, in order for me to simplify this ln of x, I have to let c equal also to 2 ln of c. There's no harm in doing this because 2 ln of c is still a constant. So I could have 2 ln of x, okay, minus 2 ln of c equals v squared. Okay, it has to be the same base, 2 ln and 2 ln. Okay, So I could simplify. So by properties of natural logarithm, we have a formula of ln of a minus ln of b. Okay, I've told this already. We have ln of a all over b. So I will perform it here. So this would be 2 ln of x all over c. Okay? So the inside function of the first term divided by the inside function of the second term of the natural logarithm. So 2 ln of x over c equals b squared. And finally, okay, we have to substitute back b squared. Okay? But v is equal to, okay, from this equation, v, extract v. So we have y all over x. So we have 2 ln of x all over c equals, this is squared, so this would be y squared all over x squared. And simplifying, we have 2x squared ln of x all over c equals y squared. And this should be our final answer for this problem. Okay? So it's pretty easy, okay, if you are already solving, or if you have already mastered solving homogeneous differential equation. So this would be our final answer. This is our general solution. Okay? So for number two, okay, we have the problem of xy dx minus x squared plus 3y squared. We have dy equals 0. So this is still our m. This is still our n. So as you can see, n is simpler. Okay? This one is much simpler than this. Is homogeneous because this has a degree of 2. 1 for the exponent of x and y for the exponent. 1 for the exponent of y. So since this is multiplication, we add the exponents of them. So it has a degree of 2 each term. So each term, we have x squared and we have 3y squared. So degree of 2. So we have to let, since m is simpler, we have to let x equals vy and get the derivative of this. This would be v dy plus y dv. Okay. So substitute all the values of x with vy. So we have vy, that is our x multiplied by y. Okay. Then we have dx, we have v dy plus y dv. Then we have minus x is squared, that becomes b squared y squared, okay, plus 3y squared, and then we have dy equals 0. So we have by squared multiplied by v dy plus y dv minus, I can distribute the minus sign. So we have b squared y squared, the same with dy minus 3y squared dy equals 0. Simplifying this, distribute. Okay, so we have b squared y squared dy plus by cubed dv minus v squared y squared dy minus 3y squared dy equals 0. So as you can see, this would cancel, v squared y squared dy and minus v squared y squared dy. So that we have by cubed dv minus 3y squared dy equals 0. And we can divide both sides, just like what we did a while ago, simplify this, by 1 over y squared. Okay? Divide by y squared, I mean. So that this would be simplified as vy dv minus 3 dy equals 0. Okay, this now is separable, variable separable. So I want all terms of v in this side and all terms of y in this side. So I have v dv minus 3 dy all over y equals 0. So we are now ready to integrate, okay, the differential equation for us to get the solution for this integral or for this differential equation. So we have b squared all over 2. Our formula, I can factor out outside the integral sign the 3. So it becomes 3 minus 3 integral of dy all over y. So that becomes 3 ln of y equals c. Okay? So we already have, again, ln of y here. Okay? Negative 3 ln of y. So what will I do is to transpose, okay, the c. So I will be including the sign, okay, minus sign. I can, because I would want to simplify this ln. Okay? So we will make c like this. Okay? So that we can actually what? We can simplify. So much pretty like this. Okay, so we have negative 3 ln of y. Consider the sign also. So we have b squared all over 2 minus 3 ln of y minus of the negative 3 ln of y equals 0. So that we have b squared all over 2 minus 3 ln of y plus 3 ln of y equals 0. I'm so sorry, it's not ln of y. It should be ln of c. Okay? ln of c. Yan. And then, multiply both sides, equation by 2. So, we have 6 ln of y plus 6 ln of c equals 0. Okay. So, now, I could easily simplify this. Okay. So, I could have b squared, factor out negative 6, okay, from them. And then, I have ln of y. Okay? Minus ln of c equals 0. I factored out the negative 6. Okay? So, this becomes v squared minus, this can be simplified as ln y all over c equals 0. And then, I can transpose negative 6 ln of y all over c on the right side so that I have v squared 6 ln of y all over c. Okay? Now, it's time to back substitute the value of b. And we will be getting the value of b here. Okay? So, that would be x over y. Okay? So, we have value of b, x all over y. So, that we have b squared is x squared all over y squared. Okay? Equals 6 ln of y all over c. So, multiply it. So, we have x squared equals 6y squared ln of y all over c. And this is our general solution for our homogeneous differential equation. So, if you don't have any questions, you cannot ask questions. Okay, you can ask questions on the comment section, I mean. So, thank you so much for listening. Again, this is a great time to study homogeneous differential equations, especially now that we are online. So, thank you so much for tuning in, and please don't forget to subscribe to my channel if you learned something from our discussion. So, thank you so much. Again, this is Engineer Abat. God bless.